We are proposing a hypothetical photovoltaic array located within San Luis Obispo County with the capacity to power San Luis Obispo City. For this system to be economically viable, various factors such as land prices, average cloud cover, and photovoltaic efficiency were considered.
Relevant power facts of SLO County. The SLO County annual electrical energy use is about 1,746 kilowatt hours per year. The population of SLO County is 276,000 people according to a 2013 census. The population of SLO City is 46,000. This gives a percentage of about 17% of the entire SLO County population is located in SLO City. This equates to a power need of about 35 megawatts. The approximate acreage per megawatt is 5 acres. This equates to about 175 acres needed of total land to accommodate a 35 megawatt facility.
This map shows the average annual energy a square meter photovoltaic panel receives during a day. This map was generated with satellite images of average annual cloud cover. Although the average energy density across SLO County varies by up to 16%, all inland areas are equally viable because the total amount of energy received in a day is so high already. Next, we assess the cost associated with transmission lines. This chart shows two things. First, for all locations within SLO County, AC transmission line systems are cheaper than DC lines. The crossover point at which DC is cheaper is approximately the distance between SLO City and Las Vegas. Second, new transmission line systems are incredibly expensive, costing hundreds of millions of dollars. As such, the solar facility should be built near existing lines so that new lines are not needed. This map shows the location of existing high voltage transmission lines. There are 3 inland corridors that the solar facility can be constructed along. To the north, between SLO and Templeton, to the east, in the plains between SLO and Bakersfield, and to the south, between SLO and Santa Maria.
This is a map showing price of land per acre in various regions. It was generated using large plots of land for sale in regions neighboring San Luis Obispo. The price was calculated by taking the total price of the lot divided by the number of acres contained in the lot. As you can see, the cheapest land prices were found in the Carrizo Plains region.
On this slide, we can see Topaz Solar Farm, which is actually the largest solar farm in the world at this time, and it's in SLO County. It uses 600 acres to provide a capacity of 550 megawatts, and it uses the same thin film photovoltaic panels that our project will use. And it provides 1,100 gigawatt hours a year. The cadmium telluride photovoltaics we are going to use are about 16% efficient. That's roughly half the maximum efficiency for solar panels we have. However, these thin panels are much easier to manufacture and much cheaper. They cost about 60 cents per watt, and one panel will generate about 75 watts. Since we need 35 megawatts, this means that 115 acres of land will be covered in panels, and that will cost about $21 million.
This chart shows the cost of constructing a 20 megawatt facility as reported by the Energy Information Administration. These values create a total cost of about $84 million to construct, causing the price per kilowatt to be $4,183. It should be noted that these values do not take into account interest rates of loans. The price per kilowatt of the 20 megawatt facility reported by the EIA will be used for calculations on our 35 megawatt facility. This was done by taking the $4,183 per kilowatt and multiplying it by the 35 megawatts. This equated to $146 million in capital costs. Since their values were taken from 2013, a 15% decrease in cost was estimated, resulting in a total capital cost of $124 million in 2015. In addition to the capital cost of constructing the facility, there is also an operations and maintenance cost. The EIA calculated this value to be $27.75 per kilowatt per year. The major portion of this goes to maintenance of the DC to AC inverters, as well as washing the solar panels 1 to 2 times per year. Comparing this to a coal facility that has an operations and maintenance cost of over $60 per kilowatt per year, with an additional cost of purchasing coal. Since all studied regions receive similar amounts of annual solar energy, and due to the high cost of constructing new transmission lines, the best place to construct this facility would be where land is the cheapest, or in the Carrizo Plains region. The total capital cost would be $124 million with an operations and maintenance cost of $1 million annually.